I am Dr. Muhammad Shoaib. In disconnection approach, this lecture is about one group CC disconnection of carbonyl compound. That is, synthesis of a range of carbonyl compounds will be discussed. Background knowledge of organo-metallic reagents and alkylation of enolates is required for this lecture. Let's start by comparing the 1,1-diX. Here is 1,1-diX and the corresponding CC disconnection. We can say that acid halides, as shown here, can be prepared by the derivatives of esters by using halide nucleophile, which will attack on the carbonyl carbon and methoxy group will leave. Similarly, the ketones can be prepared by the same method by using carbon as a nucleophile and methoxy group as a good leaving group. Moving on to 1,2-dix, and the corresponding CC disconnection, here we can see that the polarity is reversed. Here it is the positive charge and here it is negative charge. We will discuss all these four cases in this lecture. Here is the synthesis of aldehydes and ketone by acylation at carbon. This is an ester. When reacts with Grignard reagent, this tetrahedral intermediate is formed. When methoxy group leaves, ketone is formed. But in actual practice, this does not happen because the ketone is more electrophilic than ester and it will compete to react with Grignard reagent and the ultimate product is tertiary alcohol. Therefore, this problem is solved by using acid halide instead of esters. Acid halide, when reacts with lithium dialkyl cuprates, are converted into ketones, which is our required product. The above problem does not happen here because the acid chloride is always more reactive than the ketone, and the molecule of acid halide will react with lithium dialkyl cuprate to give the required ketone. Lithium dialkyl cuprate can be prepared by the reaction of cuprous iodide with alkyl lithium. Here is an example of chemoselectivity. Here are two halogen atoms and we will see that only one reacts. 4-bromobutanoic acid is commercially available and is converted into its halide. When it reacts with dialkyl copper lithium, alkyl attacks on carbonyl carbon and chloride is removed. By using this reaction, different kinds of bromoketones can be prepared by changing R group. Different compounds can be prepared. But here another problem arises that only one alkyl group is transferred and other is wasted. Therefore, to avoid wasting of other alkyl group, complexing agent can be added, such as phenyl sulfide is added to stabilize the organo-copper reagents. Here, there is only one tertiary butyl which is cleanly transferred to the product acid and replaces the chloride from acid halide. We can say that this compound can also be prepared by Friedel-Crafts reaction. But the problem is that in Friedel-Crafts reaction, sometimes carbon monoxide is removed, so we don't get the required product. So it is a better method than Friedel-Crafts reaction. In synthesis of 4,4,4 propylene, monomethyl ketone was required, which was prepared by the diester. First, this diester was hydrolyzed. Only one ester group was hydrolyzed and was converted into its acid halide, and when it reacts with dimethyl copper lithium, our required product monomethyl ketone was formed. Next is the preparation of aldehyde by direct formylation of organolithiums with N,N dimethylformamide. Here is the molecule of N,N dimethylformamide. When it reacts with alkyl lithium, the following intermediate is formed. In the presence of acid, this amino group is removed and an aldehyde is formed. It can be used here. For example, we have 1,5-diiodonaphthalein. When it reacts with butyl lithium, and DMF, one iodine is replaced and formyl group is attached on the naphthalene. Mechanism will be this iodine atom will be replaced by lithium, and then this naphthalene, the carbon of naphthalene will attack on carbonyl of DMF and the formylation will occur. Similarly, in isothiazole, when reacts with butyl lithium, hydrogen is exchanged for lithium and the formylation takes place at this position. Next is the use of Grignard reagents. Grignard reagents are usually better than organolithium in these type of reactions and may be even better with a catalytic amount of copper. A good example is the coupling of Grignard reagent derived from the following molecule. First, this alkyl halide will be converted into Grignard reagents in the presence of magnesium and ether, then it will react with this protected nitrile to give the excellent yield of ketone group. When Grignard reagents reacts with nitrile, the intermediate is formed, and in the acidic condition, hydrolysis occurs to obtain a molecule of ketone. We have tertiary amine which are similar to DMF. There is only one difference. In tertiary amine, there is an R group, while in DMF, there is a hydrogen atom. But these amides are very less reactive, therefore these are nearly useless in these type of reactions. Here are some other examples which shows the intramolecular reactions to prepare 5 or 6 membered cyclic ketones. This compound will react with magnesium and ether followed by hydrolysis to give cyclic ketone. The detailed mechanism of this reaction is given here. First of all, this alkyl halide will be converted into Grignard reagent. Then this nucleophilic carbon will attack on this carbon, and when hydrolysis will occur, ketone is formed. Similarly, there is another example of intramolecular cyclization to form a cyclic ketone. In all these reactions which we have studied so far, nucleophilic reagent is an organometallic derivative of lithium, copper or magnesium, and the electrophile is an acid chloride, a tertiary amide or a nitrile. Next is the synthesis of carbonyl compound by alkylation of phenol. Here is a ketone. When we disconnect this R1, we obtain alkyl halide and an enol. But when we try to synthesize by the same method, this enol can be obtained from a ketone or acetone. But the synthesis is not possible because the ketone undergoes self-condensation by aldol reaction. Therefore, this problem is overcome by using LDA. First, all the molecules of ketones are converted into lithium enolates, and then the reaction is possible. Another alternative is to use the ketoester instead of this ketone. The mechanism is given here. Diisopropylamine is converted into diisopropylamide, lithium diisopropylamide in fact, by the use of butyl lithium in the presence of THF, and when it reacts with acetone, enolates of lithium is formed. Here is another example of a synthesis. First of all, this cyclic ketone will react with LDA it will remove the acidic proton and will be methylated. Then in multi-step reaction, this group is attached here. Then on other side, a cyclic ester is reacts with LDA, and this carbon will attack on this electrophilic carbon, and both moieties are joined to give the required product. For alkylation of ketone, and alternate to a very strong basis to modify the ketone by using an ester, that is functional group addition. For example, we have an acetone molecule. By using FGA, an ester group is added. So when we use this starting material in the presence of a base, this carbon becomes a nucleophile and the alkylation will take place here and we get this product. And to get rid of this ester group, hydrolysis and heat brings about the following product. The mechanism of the last step is given here. Next is the synthesis of 3-methyl pentanoic acid. When this 1,2-di-CC is disconnected, we obtain an alkyl halide and this synthone. This melanoate can be used as a reagent for these type of synthones. In synthesis, this is melanoate in the presence of a strong base. The proton is removed from this carbon and this carbon becomes nucleophile and it will attack on this electrophilic carbon and bromine is removed. And then by hydrolysing one ester group and decarboxylation brings about the following product. Similarly, the analysis of this compound 1,2-di-CC, we obtain an alkyl halide and the synthone, which can be equivalent to an acetone. And to avoid a strong base, FGA takes place and an ester group is added. When we synthesize the target molecule, we took this ketoester and it is alkylated by using alkyl halide. Similarly, the hydrolysis and heat give us the target molecule. Next is conjugate addition. Here is 1,3-dix, 1 carbonyl is 1, 2 and 3. This group is disconnected and heteroatom will become a nucleophile and it can be prepared by the conjugation reaction. The corresponding CC disconnection is here. And to bring about the conjugate addition, Grignard reagent is used in the presence of Cu1, cuprous iodide. Here is the reaction. Here is another example. First, it is disconnected here by using Friedel-Crafts reaction and we obtain this carboxylic acid. Next is 1,2,3,1,3 disconnection. We obtain an isopropyl halide and a double bond. During synthesis, we took this ester and reacts with isopropyl magnesium chloride, we obtain this intermediate, and in the presence of polyphosphoric acid, cyclization takes place to get the required target molecule. Next is that the aromatic compounds are also good nucleophile to add in conjugate fashion under Friedel-Crafts reaction. And here one more advantage is that no organometallic reagent is added. There is 3,3-diphenyl propanoic acid. When one phenyl is disconnected, we obtain cinnamic acid, which is commercially available, and then this cinnamic acid will react with benzene in the presence of AlCl3. We get 3,3-diphenyl propanoic acid. Next is the preparation of a diol. Here this OH, this methyl, and this CH2OH are all is cis. When a chair form is drawn, this OH, Me, and CH2OH, all these three groups are in cis position. And when we bring about FGI, this CH2OH is converted into an ester. This ketoester can be disconnected in two ways. One is A path and other is B path. In A path, this allyl group is removed, and in the B part, this methyl group is removed. In both cases, we expect the conjugate addition. But this path A is preferred because when this allyl magnesium bromide reacts with this ketoester, it brings about the conjugate addition at this carbon. But in path B, when we try to bring about the conjugate addition, there are two possibilities: that this methyl can be added to this alpha carbon, or it can be added to this gamma carbon, which is more exposed. So the synthesis followed the A part. This ketoester, when reacts with allyl magnesium bromide, it gives this intermediate, which when reduced in the presence of lithium aluminium hydride, the ester is reduced to the CH2OH alcohol group. And that's all about one group CC disconnection of carbonyl compounds. Thank you for the listening and watching. You can ask any question from me.